So we'll discuss the last topic in this bolted joints today. So far we've seen two different cases. One is when the eccentric load is in the plane of the joint, that is one case. The other case what we have considered is when the eccentric load is perpendicular to the plane of the joint, and that too it is perpendicular to the axis of the bolt. So now today we'll see a eccentric load which is in the plane perpendicular to the axis of the bolt, and also the load is parallel to the bolt axis. See, you can see in this diagram now. Here, this is the plane of the joint. So, plane of the joint is something like this, and this load is perpendicular to the plane of the joint, and also the load is perpendicular to the axis of the bolt. Let me take the pen. So here this is going to be the plane of the joint, and this load is perpendicular to the plane of the joint. Then these are the axes of these two bolts. So this load line of action of this force is parallel to this axis of the bolts. So this is the third case. So earlier case we have seen the previous case is okay. I'll go back one step. So here, in this case, you can see that here, this is the plane of the load. So, and this is the axis. So the axis is, the load is perpendicular to the bolt axis. Okay. So now it is opposite to that one. Okay. We'll see how we are going to analyze this one. So now, like in earlier two cases, here also what you need to do is you need to look at two conditions. One is what is the effect of transferring this force to its centroid of this bolted system. So in that case, what you have to do is you need to find out what is the direct load and what is the moment. So again, we need to look into because of this direct load, what is the stress or what is the nature of the stress, and because of the moment, what is the nature of the stress. So in our previous two cases also we analyze like that only. So in this case also we'll analyze in the same manner. So that means first we need to identify what is the magnitude of load or what is the effect of this load by transferring from this plane to the plane which passes through the centroid of this bolt system, then its effect. So now if you look at this, here this load if you transfer to here, this will go to the effect is a direct load of magnitude P, which is acting in the same direction, and it should do that it is going to have a moment. So that moment is nothing but here the tilting point is going to be this in this case because of this one. So this load multiplied by this eccentric or offset distance, whatever you call it, that offset distance will give you the moment value. So that moment is going to be because of this one here, it is going to be a clockwise moment. So if I take moment about this point C, this load is going to tilt this bracket in the clockwise direction. So it is going to be the moment is clockwise. And also I can see that, so this is our bolt axis and the load is also in the direction of bolt axis, means obviously it is going to be create a bending stress or bending load. This is moment is going to be bending moment and stress is going to be a bending stress in this. So that means because of direct force there is a normal stress, even because of this movement also there is a normal stress. So that means these two forces will create a normal stress in these two bolts. So we need to add those two stresses so that we get the total normal force. Then from that you can find the dimensions of the bolt. So now we'll see that step by step. So a bracket fixes to the steel structure by means of 4 bolts. So here you have only one view. At this location there are two boards, and even at this location also there are two boards. So it's shown in figure. It is subjected to an eccentric force P at a distance E from the structure. So from this point onwards, it is subjected to an eccentric. The force P is parallel to the axis of the each bolt. Like we already told or we already discussed, here this axis is perpendicular to this bolt axis. The left side, two bolts are denoted by 2. So here, this side, whatever two bolts are there on the left side, they are denoted by 2. On right side, they are denoted by 1. So now, similarly in the previous analysis, here also we make some assumptions. Those assumptions are the bracket and steel structure are rigid. That also what we made in the previous case, so that only the bolts are capable of elongation. So this bracket and this structure is rigid. The bolts are fitted in a rim and ground holes. Same assumption what we made in the previous case. The bolts are not preloaded and there are no tensile stresses due to initial tightening. Okay, so these are the assumptions. So what we made in case of this one, even there is no stress concentration, and also we assume that all bolts are identical. So these are the same assumptions what we made in case of the previous case. When the load is acting to the axis perpendicular to the axis of the bolt, here also same assumptions holds good. So now with these assumptions, we'll try to find out what is the effect of this eccentric load on these bolts. So for that, the bolts are subjected to a tensile stress on account of following two factors. So what are those two? One is direct tensile stress because of force P, which is parallel to the axis of the bolt. So that means the direct force will create a tensile stress. That's why we'll call it as direct tensile stress. Then a moment will be created. That moment will also create in a bending stress. So tensile stress, bending stress is nothing but a tensile stress. Maybe sometimes it is also compressive, but we'll consider only the positive stress value because this is a tensile. So in order to get the maximum stress, you need to consider positive tensile stress. Due to the tendency of bracket to tilt about the edge C due to eccentric force P. So then, since our assumption is all bolts are identical, so that means the size of the bolts is same. The total force, whatever may be there, the direct force is equally shared by all the bolts. So therefore here your P1 dash and P2 dash, that is nothing but the direct tensile stress, a tensile load. So on the each bolt which is given by P1 dash and P2 dash. P1 dash is the tensile load on first set of bolts. So if we take that, if we go back to the diagram here, this is the first set and this is the second set. So P1 dash is nothing but the direct tensile stress acting along this axis, that is P1 dash. For this bolt set, it is P2 dash. P2 dash is going to act. If I apply or if I transfer to this force to here, that is going to be P. So now the magnitude of this P1 dash or P2 dash, it is going to be same and also equal to P divided by the number of bolts, where N is the number of bolts. So here in this case, you said total number of bolts is 4. So you have to take P by 4. Suppose you have more than 4 bolts, order may be the number of bolts. Other than 4, if you have to take those total number of bolts. So don't consider the number of sets here. Whenever you calculate direct effect of direct force, always you need to find out or always you need to consider what are the total number of the bolts. In any case, whether in this case, that is when parallel eccentric load is parallel to the axis of the bolt or eccentric load perpendicular to the axis of the bolt, or maybe first case also. So all the cases, what you need to do is you need to consider they are the load is equally shared by all the bolts. Means you need to consider total number of bolts, not the total number of sets of bolts. Okay, so only number of sets come into picture in case of a bending load or bending stress. Okay, right. So that's why here we'll take this here. In this case, P1 dash and P2 dash is nothing but. So why we consider only here, even though you have a 4 bolts, here we said P1 dash, P2 dash. We haven't calculated P3 dash and P4 dash. Why we are not calculating P3 dash and P4 dash? So P3 dash is nothing but equal to P1 dash. Even P4 dash is also equal to your P1 dash, which is equal to P2 dash. So that's why we are not writing P3 dash and P4 dash. So only one is sufficient because it is same for all the bolts. So The important point what you need to remember is you need to consider this one as total number of bolts, not the number of sets of the bolts. So that is the important point you need to remember. So then the tensile force due to tendency of the bracket to tilt. So we know that here the bracket is going to tilt here about this point, about point C here because of the eccentric load. So because of that, if the bracket is tilting in this direction, if the bracket is tilting like this about in the clockwise direction, this bolt will elongate in this direction, even this bolt will also elongate in this direction. But since the bracket is tilting something like this, originally it is something like this, here this point is tilting to something like this, so this much is going to be the elongation for the first set of bolts, and this is only this much is going to be the elongation for the second set of the bolts. Here if I take this is delta 1 and this is delta 2, so now delta 1 is large when compared to delta 2. Why delta 1 is large here? Since this point or this axis is far away from this tilting point. Here our tilting point is C. This is the distance what you have for a first set of bolts. Only for second set of bolts, only this is the distance. The distance is very small from the point of tilt to the axis of the bolt. So therefore, always you need to consider the bolt which is having highest deformation or which is far away from the tilting point. So we won't consider this. So we'll consider only this set of bolts because these bolts are far away from this tilting point. Once you identify that, then we need to identify what is the force. Because of this movement, what is the tensile force acting on this set of bolts. So for that, whatever assumptions we made in case of the previous case, these assumptions are valid here. So delta is since our delta. So what is going to be the elongation here? That is proportional to the tensile force. So based on that, we can derive an expression for what is the force in each bolt. So that we already seen in the previous class. If you apply the same procedure here, you are going to get the same expression. What you got earlier, you will get the same expression here also. Your P1 double dash is going to be PE into L1 divided by L1 square plus L2 square. And P2 double dash is nothing but PE into L2 divided by L1 square and L2 square. So I think 2 is missing here. So if you go back to the earlier derivation, in this case, okay, when the load is, oh yes. Yes, if you come to here, so what you got it is, in case of bending moment, your expression for this one, okay, it should be 2 times, something like this. Here the formula should be 2, here also the formula should be 2. So if there are 4 number of bolts, suppose if you have only 2 bolts, then it's okay. So that is, be careful about that. So in this case, I'm not sure how many bolts are there, only 2 bolts are there. So then instead of here 4, if I take this one as a 2, means here I have only 1 bolt, here also I have only 1 bolt. In that case, then the formula is going to be like this. So P into L1 by L1 square plus L2 square, and P2 dash is nothing but PE into L2 divided by L1 square plus L2 square. Suppose instead of 2 bolts, if I have a 4 bolts like I said earlier, here at this location you have 2 bolts, even at this location also you have a 2 bolts. So in that case, you need to consider the equation as, here you need to consider 2, here also you need to consider 2. If there are 2 bolts, suppose if there are 3 bolts, you have to consider 3 here, you have to consider 3 here also, because all the bolts are at the same distance from the point of tilt. So therefore, you can take it as 3 times. So like that. So if it is only 1, so L1 square plus L2 square only. If there are 2 sets, you need to take 2, 3 sets, you need to take 3. So like that, we can determine the what is the tensile force acting because of the movement on this set of bolts. So once you calculated this, so now we can see here, this is a tensile force P1 dash, even this is also a tensile force. So and also we know that the bolt which is located far away from the tilting point is subjected to the maximum tensile force because of the tilting of the bracket. You need to consider that So since both are tensile forces, you need to simply add that so that you will get the total tensile force acting on each bolt. So that means simply you have to add P1 dash and P1 dash plus P1 double dash, provided your P1 double dash is going to be the highest tensile force. If not, you need to take, if P2 double dash is going to be the highest force, you have to add P2 dash to P2 double dash and so on. So like that, you can solve the problems. Okay, so once I got the resultant, in general, the bolt which is located at the farthest distance from the tilting edge C is subjected to the maximum force. That's what we already discussed. So then the resultant force is nothing but the summation of those two. So in this particular case, bolt 1 is farthest from the tilting point C. So I'll consider only, while finding out the resultant tensile force, I'll consider only the forces acting on bolt 1. So which is going to be P1 dash plus P1 double dash. So then once you got this, so then you can use the your design equation, that is sigma 1 is equal to P1 divided by A, where P1 is the resultant load in the bolt set 1 divided by A is nothing but area of the bolt. So from this you can calculate the area, or you can go for your area is nothing but it is pi by 4 dc square. Pi by 4 dc square. So sigma 1 will be given to you. So then we calculated P1. So from that first we can calculate A. From A you can calculate DC. So from once you got the DC value, you can pick the standard diameter, or you can find the D as nothing but DC by 0.8. So from this we will get some value. So then according to this value, you have to choose the standard value from the data book. So that is the way you need to solve this problem. Or else the other way is, first we'll calculate only area. So then based on this area also you can pick the standard diameter from the data book. So whatever may be the area, let us say if I got 100 mm square area, by solving this equation I got the value for A is 100. So now I'll open the data book and I'll take the last column of the table 8.2 or 8.3 I think. So in the table you have to pick the area which is 100 or more than 100. So but you cannot take a bolt which is having less than 100. So you have to look at for the 100 mm area or more than 100, slightly more than 100, or next number which is higher than this 100. Like that you need to choose. Then you need to identify what is its corresponding nominal diameter. Then you can say that that is going to be the diameter of the bolt required for this application. So like that you can select the problem. Okay, so this is how you can analyze this bolted joint subjected to an eccentric load when it is subjected to a load which is perpendicular, which is parallel to the axis of the bolt. So now we'll consider one more problem on this also, and then we can close this topic. Not only this topic, we'll close this bolted joints with this problem. So maybe in next class we'll take up the next topic, that is cotton joints. Okay, so you note down this problem, then we'll try to discuss the solution and you can complete the solution for this problem also. So take a 5 minutes time to note it down. Just note it down. Once it is done, just inform me so that we will discuss the solution for this also.
So completed, sir.
It's done? Okay.
Yes, sir.
Yes, yes. Okay, so we'll see the solution now. So you can see that from the diagram itself, you can see here it is subjected to an eccentric load which is parallel to the axis of the bolts. So this is the axis of the bolt for A, B. This is the axis of bolt for bolt A. So the here this is the load. The load is parallel to this axis of bolt, and from these two views you can see this is one view and this is the other view. You can say it is front view and this is the side view. Then you can see that only there are two bolts. This is one bolt and this is one bolt only. So if there are more than one bolt at this location, in this view we will see those bolts. But here in both the views you can see that at the given location there is only one bolt, means the total number of bolts is only 2. So that is clear, and also has given the distance of the bolt axis from the tilting point. This is the tilting point here because of this load. So the distance between the bolt A or from the tilting point to axis of bolt A is L1, and the distance of between the axis of bolt B to this tilting point is taken it as L2. So L1 is given as 50 mm and L2 given it as 200 mm. Then the distance from line of action of this force P to the point of tilt C, this distance is taken it as L, and that distance is also, that length is also given as 400 mm. So distances are given, and this applied force he has given it as 25 kilonewtons. And he said, clearly said, you can in the image without looking this diagram also, he given the statement here. There are 2 bolts at A and 2 bolts at B. Okay, so maybe inside you cannot see that. If you go for the top view, then only you can see that number of bolts here. So there are 2 bolts at A. He is saying that at this location there are 2 bolts and 2 bolts at B. So that means there are total number of 4 bolts are there. Like I said earlier, it's not 2. There are 4 number of bolts, 2 at this location and 2 at this location. In the problem description, he has given that. Okay, right. So the cast iron bracket fixed to the steel structure as shown in figure. Supporting load is given as 25 kilonewtons, and he said that there are 2 bolts at location A and 2 bolts at location B, and the eccentricity of that load is from the point of tilt is 400 mm. Then determine the size of the bolts if the maximum permissible tensile stress in the bolt is 15 Newton per mm square. So that means the tensile tensile load, permissible tensile stress in each bolt it is only 15 Newton per mm square. So then for that, what should be the size of the each bolt? That is the question. So as we discussed in the theoretical concept, so we need to find out what is the direct tensile stress because of P. Then you need to find out what is the direct tensile stress because of the bending moment. So for that, first you need to calculate what is the primary force on each bolt, that is P1 dash. Then what is the secondary tensile force, that is P2 dash. Then you need to sum up those two. So from that you will get the resultant tensile load on each bolt. So from that you can calculate the diameter of the bolt also. Okay, so now if I see that tilted portion of this one, that means here this bolt set is going to elongate more and compared to this one. Why? Because this is going to be the farthest from the tilting point. So here this is the nearest to point C, whereas this B is farthest from point C. So therefore your design criteria should be the bolts which are located at this B, point B, not at point A. So therefore what you need to do is you need to find out what is the tensile stresses because of direct force as well as because of bending moment at this location now. So for that, okay, this is the given data in the problem. So we already seen about that. Then direct tensile force is nothing but the applied force divided by the total number of bolts. Here we said there are 4 bolts, so therefore total number of bolts should be 4 here. So 25 kilonewtons he has given the load. So we'll convert that one into newtons. So therefore it becomes 25,000 newtons divided by 4 is nothing but 6250 newtons is going to be the direct tensile load on each bolt. Then we need to find out what is the tensile load due to bending moment. So that is given by So I already said that it is the tensile stress is maximum for B, not for A, because B is far away from point C. So therefore the formula for that is P into L2 divided by C. Here earlier also I told, because there are two sets of the bolts at each location, you need to multiply this formula by 2. If there is only one bolt, you have to take L1 square plus L2 square. Because now there are two bolts for each set, you have to multiply by 2 here. So he has given L1, L2, everything is given to us. So of course E is given in terms of L. So L he has taken it as E. So you can take that and you can substitute that 25,000 into E, where E is 400 into L2 is 200 divided by this one. We get this is going to be the tensile load because of tilting of the bucket, or because of the bending movement created by that eccentric load at bolt B. So now this is a tensile force and this is a tensile force. Both are acting in the same direction. So you need to add these two so that you will get the resultant force. The resultant force is nothing but P2 dash plus P2 double dash, which is nothing but 6250 plus this one. So this is going to be the resultant tensile force on each bolt. So that is, this is the maximum tensile force which is going to act on the bolts. So 29,779.41 newtons. So once you know that, if I know the tensile force, I can calculate the tensile stress in the bolt. So therefore, the tensile stress is nothing but P2 by A. So that he has given, that allowable tensile stress, he has given it as 50 MPa. So P2 we already calculated. I'll substitute for the P2 divided by A. If I solve this, I'll get A is equal to 595.59 mm square. So now I'll open my data book. So from the data book, I can choose the size of the bolt. So now I'm giving the task to you. So just open your data book. So tell me what is the size of the bolt you need to choose for this application. So where the required thing is the bolt area should be at least 595.59 mm square. So either it should be 595.59 or next value. So now you look at it in your data books, then you tell me that. So mean that you can note it down and then also you can tell me the answer for that also. Okay. Anyway, I shown that here. Okay. So if it is in the presentation mode, okay, it's okay. Then you open your data book and tell me what is the value of that. So I'll ask specific people, otherwise nobody will respond. This 330, Ganta Shushank, are you there? ఉన్నారా నువ్వు 330, రోల్ నంబర్ 330. మాట్లాడాడు 330 గారు ఉండ అసలు
సార్ ఉన్నా సార్.
ఏం రెస్పాండ్ అవ్వడానికి ఎంతసేపు టైం పడుతుందిరా? ఫోన్ ఎక్కడో పెట్టి ఎక్కడ ఉన్నావు నువ్వు?
కాదు సార్.
డేటా బుక్ ఉందా నీ దగ్గర?
పీడిఎఫ్ ఉంది సార్.
పీడిఎఫ్ లో చూసి చెప్పగలవా?
చెప్తా సార్.
You tell me the answer. So you know how to look at how to identify the data from the data book. Photo వచ్చా నీకు డేటా బుక్?
yes sir.
Then okay, do it. Asha Honda 355.
సార్
డేటా బుక్ ఉందా?
సార్
డేటా బుక్ ఉందమ్మా నీ దగ్గర?
ఎస్ సార్ ఎస్ సార్
చూడు, చెప్పగలవా డయామీటర్ ఎంతో?
చూస్తున్నా సార్.
చూడు, ఇద్దరి మీద ఆన్సర్. లేటరల్ ఎంట్రీ LE1 ఉన్నారు నువ్వు?
ఎస్ సార్.
ఉందా డేటా బుక్?
ఎస్ సార్, చూస్తున్నాను.
ఎంతసేపు చూస్తారా? 2 నిమిషాల్లో అయిపోద్దా చూడటం? ఎంతసేపు చూడాలి దాన్ని? సరే, టెల్ మీ. అందరూ ఒకే ఆన్సర్ చెప్తారో లేదో చెక్ చేద్దాం. 325. ఉదయకిరణ్ ఉన్నారా?
సార్
డేటా బుక్ ఉందా?
ఉంది సార్.
చూసి ఆన్సర్ చెప్పినాక ఇది ఆ ఏరియా
చూస్తా సార్.
రైట్ ఓకే. సో మైక్ ఆన్ చేసి చెప్పలేకపోతే పుట్ ఇట్ ఇన్ చాట్ బాక్స్. ఏరియా ఎంత మనకి? 595.59. 595 mm² ఏరియాకి నువ్వు ఏ బోల్ట్ సేవ్ చేస్తావు చెప్పు, చూసి చెప్తాను. ఎవడ ఆన్సర్ చెప్పలేదు ఇంతవరకు నాకు. M30 M30 అంటే వచ్చిందిరా? ఎవరిది M30 కామెంట్ పెట్టింది? LE1 M30 అంటే వచ్చింది నీకు. వాట్ ఈస్ ద ఏరియా చూసే? What is the area for M30? Put it that in a comment box. Not only answer. So why you are taking that one? You need to tell that answer also. M30. What is the area for M30? It is 561 only. What is the area required for you? ఏరియా రిక్వైర్డ్ ఈస్ 595. 595 ఎక్కువ 565 561 ఎక్కువ నాన్న నీకు. మళ్ళీ M36 అంటే M30 కాదంటే M36 అది కూడా తప్పే. యూజ్లెస్ కదా, నీకు డేటా చూడటం రాదు సరిగ్గా. డేటా బుక్లో ఏ డేటా చూస్తున్నారు నువ్వు? LE1 M36 ఏరియా అంతా $36 is also wrong answer. 36 is not correct answer. 20.
సార్
36 ఎలా వచ్చిందిరా? దానికి ఏరియా ఎంత 36 కి?
870 ఉంది సార్. 817 ఉంది సార్.
నీకు కావాల్సింది ఎంతరా?
595.
ఎందుకు అంత ఎక్కువ తీసుకున్నావు? అంత ఎయిర్ సైడ్ ఎందుకు తీసుకున్నావు నువ్వు? 33కి 35కి ఎంత?
సార్ 33కి 694 ఉంది సార్.
694 590 కంటే ఎక్కువ తక్కువ?
ఎక్కువే సార్.
మరి ఏం తీసుకోవాలి అప్పుడు?
33 సార్.
మరి 36 ఎందుకు సెలెక్ట్ చేశాను
సార్? అంటే వేరే టేబుల్ చూసినట్టున్నాను సార్, అది దాంట్లో 36 అవును చూసుకోలేదు. అది
ఏం చూసా మరి? డేటా బుక్ ఇచ్చి ఆన్సర్ ఇచ్చి చూడరా అని చెప్తే నేను అది చూసుకోలేదు సార్ అని చెప్తే ఏంట్రా ఆన్సర్? ఓకే రైట్ ఇట్. ఇంకొకటి ఎవడు సెలెక్ట్ చేసింది 55 ఉన్నాడు, ఇంకా వచ్చాడా లేదా అక్కడికి? అయ్యా చూసావా లేదా?
సార్
ఎంత ఆన్సర్?
33 M33 సార్.
M33. ఇప్పుడు చెప్పిదే M33 అన్నా, నువ్వు చెక్ చేసావు దాన్ని కరెక్ట్గానే?
చేయదా?
ఓకే రైట్. మరి టైప్ చెప్పొచ్చుగా, నీకు 33 అనగానే ఏమంటే ఆన్సర్ నువ్వు చెప్పాలి కదా. సో ఫస్ట్ మిడ్ పేపర్స్ కరెక్ట్ చేసాము మొన్న. 2 రోజులు సెలవు వచ్చాయిగా. ఎంత చండాలంగా రాయాలంటే అంత చండాలంగా రాశారు పేపర్లు. మరి ఈ రకంగా చదివితే మీరు ఒకటి కూడా పాస్ కారు. నేను చెప్తున్నా కదా, నో బడీ ఈస్ గోయింగ్ టు పాస్ దిస్ ఎగ్జామినేషన్. ఆన్లైన్ క్లాసులు కదా అని చెప్పేసి కూర్చొని ఏదో టైం పాస్ చేస్తారు ఇంటి దగ్గర కూర్చొని. నాకు అర్థమవుతుంది అది. Okay, you complete that problem and then upload it in the classroom. So with that we close this topic also. Welded joints also, bolted joints also. So it is over. So now the task is for you. You have to solve different possible types of problems on this. You take any textbook, from the textbook you can do it. So in next class we'll take up quarter joints and we'll see. Once everything is completed, then time is there, then we'll come back about to all these things again. We'll discuss some more problems, but first for time being, first we'll try to complete all the syllabus, then we'll come back. So answer is this. If you want, you note it down this answer. Then upload in the classroom.